Okay, hello everyone. This is TM 105 meeting 4. Again, there will be two recordings for meeting 4, so I will split the recording in two. This is the first part of the recording. Let me go to the objectives. Few objectives, basically two main ones. The first one is the importance of something called a math class, and the second objective has to do with loops. You see, loops were introduced in meeting 3. However, we will focus a lot more on loops and perform all the needed code and how different ways the loops can be used. So the main objective is to understand what for loops are for, what while loops are for, what's the advantage, and sometimes we have statements that can support a loop, such as the break and continue. And just like we did with the if statement, and we nested if statement, you can write nested loops, and you can see why do we need nested loops. So I will explain all of these, and of course I will introduce the math class. So let me first start by introducing the math class, then I will go over to loops. You see in the slides there's this exercise, like write a Java program that inputs from the user the radius of a circle as a real number, calculate and print the circle's circumference and area rounded to 2 decimal places, and they gave you the formulas. You see, when you are working with a circle, you need the value for pi. So the circumference is 2 pi r, and the area is the pi r squared. So let me try to write this program where I will take from the user this value r, representing the radius, and then I can provide the output. I will go to my NetBeans, and let me start by a new project, Java application. Next, finish, just give it whatever name you want, it doesn't matter. Alright, it might take some time to create the new project. Okay, here's my project. Let me remove this tab, and I will, for clarity, I will remove the comments. However, you can always keep the comments. Again, this will be an excellent review for how to take input from the user. So whenever you need a Java program to take input, start by the import statement. So this is import the java.util.scanner, and the first line in the main method should be declaration of scanner. Well, not necessarily the first line, but before using the scanner, so it's better to be first in order not to forget it. So scanner input is equal to new scanner of system.in. You see, I declared my scanner, so I imported the scanner and I declared my scanner. All right, now let me declare the radius and take the radius from the user. So again, in my declaration section, they needed to take the radius as a real number, so this is double, means decimal points are valid. I will call it radius instead of calling it r. This makes more sense. Now let me provide a prompt to the user, system.out.print. Enter the value for radius, and I will read it and store it in radius. So radius equal, because I need to store the value in this variable, and now I will read it using the scanner. The scanner was declared as a variable called input, so input references the scanner, so this is input dot, and I will use the next double, so input dot next double. Now I read the scanner. Alright, now I can do my calculation. First, let's start with two variables. I need the circumference and I need the area. Now you can go to the declaration and declare them, or you can declare and directly do calculation. I will go to the declaration. You see double radius, I will put a comma, I will add the circumference. let me call it perimeter. This is more technical, by the way, even though they ask for the circumference here. Let me check the slides. You see, they asked for circumference, but we know that in mathematics we call this the perimeter and the area, so it's fine. I will call it perimeter and area. It doesn't matter. I just like my variables to have clear names. Now, calculate the perimeter. Perimeter is equal to 2. I need to multiply it by the value of pi, and I need to multiply it by radius. Now I will fill this value. I will keep it empty for the time being. I will fill it at a later time. And the area, this should be the value of pi times r squared, the radius squared. So this is radius times radius. However, I will be modifying this as well. You see, these are the logic of my two equations. Now I need the value of pi. Well, one assumption for the value of pi is to write it as for example 22 divide 7. However, be very careful. The following was explained in meeting 3. This is integer division. You see, I am dividing 22 by 7. I will only get 3. I will not get the 3.14 whatever. So divide at 22.0. Now I will get a real number. So always be careful of your division. Let me do the same for the area, and then I will modify it. Now let me provide output. System.out.printf. Circumference equal, I need %.2f, I will round it. Go to a new line, /n. Area equal %.2f /n. Go to a new line and give it the values. You see, the circumference I called it perimeter, and the area I called it simply area. So now I am printing the values that I received for circumference and for area, and I called them perimeter and area. Let me do this first run. Enter the value of radius. I will assume that the radius is going to be 3.46 for my calculations, and this is the circumference and area rounded to 2 decimal places. Alright, now this might be correct. I am not 100% sure, because I definitely was not able to achieve a high accuracy for the value of pi. Well, instead of doing the following, here, let me remove this line. Let me copy these. I'll put them over here. You see, I duplicated my work. I will put another calculation. I'll put the value 3.1416. 3.1416. Like, this is the value of pi that I might think is a good approximation. So calculating it or providing an approximate value and providing the same result. Let me test the difference. Let me test the accuracy. 3.46, this is the value I am using. Now you see I have different values. Okay, I have different values. Well, this is very common because I am using different values of pi. But still, are my values accurate with this approximation? Well, I can't really tell. So let me go over here, add another line, and I need this time Java to help me with the value of pi. So this is the importance of the math class. You see, the first objective is to know that in Java there is something called math. You write it with an uppercase M and you put a dot. There are a lot of mathematical operations you can do. One of them is called pi, P-I, both uppercase. You see, math math.py. This gives you probably one of the most accurate values of pi. However, it's not the value of pi, because we know that pi is a never-ending number and it cannot be represented properly in Java. But this is the most accurate representation of pi you can get. So math.uppercase P uppercase I, this is the actual value of math.py. Now let me run my code. You see, I will get three different output. 3.46, these are the values. So you see, my approximation 3.1416 was somehow accurate, but was it really very accurate? You see, when you performed rounding, you achieved accuracy. What if I did not round? Here, let me remove the .2f. Let me just present it with 6 decimal places, and if I need more, I can use the print or println. Let me run it now. 3.46. Alright, now you see completely different values. You see, in my first approximation, 22 divide 7, of course I received numbers that are very weird. In my 3.1416, I received a little bit of accuracy. The only problem was after 4 decimal places, or after 3 decimal places in the case of the area. When I used the math.py, I received better accuracy. However, still, this value might not be the exact value. Anyway, but this is just to introduce the importance of math.py. So now let me show you the whole program. I will remove all of these, and this is how the program should have been written. So take a value of radius, and instead of doing calculation or writing your approximation, use the help of the math class. This is math.py. Now the math class is more meaningful, has a lot more than just showing you math.py. Let me take another example. Let me go to the meeting 4 exercises. Here, I will reduce the font a little bit. You see, in the writing Java programs, the first example, question 1, this is based on the math.py. It says, read from the user a real number that represents the length of the side opposite the 30-degree angle. You see, when you have the 30, 60, 90 degree, I am sure you have taken this in your school. Opposite 30, if you take the value as x, now you can easily calculate the other side, and you can calculate the hypotenuse. Well, the other side is the square root of x, x square root 3, and the hypotenuse is twice the value of your x. Now, instead of doing the calculations, sorry, there is an equation for the area, and they told you that if you have this value x, you can calculate the area, which is half base times height. So this gives you the half of x squared square root 3. So x times x square root 3, and then divided by 2. So if you have the value of the side opposite 30, you can calculate the area using this equation. Now notice that I need to calculate the value of square root 3. Well, yes, I can go to my calculator and I can try to figure out this value, and then I can use it as actual value or approximation in my program. However, I know that there is something called a math class, so I can use it. So let me write this program. Let me go to NetBeans again. I will keep the same draft I will be using. I will delete it. Now I have the scanner already declared. The scanner is ready. I need to declare as let's say a double, and even though they said it is the value X, I will call it side. Let me provide a prompt. So system.out.println, enter the value for the side opposite 30. Side is equal. I will read the value of side. The scanner is input. So this is input dot next double. Now I took this value. I took the value of side. Now I can continue my calculation. You see, I need to declare area. So let me go to the declaration. It's a double as well. So here is area. Now I can calculate it. Area is equal. I need half. We mentioned this before, and it's good to always mention it. Never ever do something like this. You see, this will give you 0. This will give you 0. If you multiply this by anything, it is 0, because you are using integer division of 1 divide 2. 1 divide 2 is 0 dot. That's it. Integer division. Java is going to ignore whatever after the dot. So either put 0.5 or 1.0. Always make sure to use double division, even if you are storing the value in a double. Always be careful about your division. So half. Now I need to calculate the square root. Math.sqrt, square root, sqrt of side. So math.sqrt of side, of 3, sorry, not of side, of 3. So this will give me the square root of 3. So now I have half. I have the square root 3. I need to multiply it by side squared. True, I can do side times side. But what if you had a larger power? Like, do you keep on multiplying the value, or do you use a loop to calculate this multiplication? You see, even raising to a power, this is provided by the math class. So I will call the math.pow, power. And it tells you, start with the base. The base is side, put a comma, and raise it to which power? I need side to the power 2. So math.pow, this will calculate the side squared. Now I have the area. I can provide it as output. So system.out.printf, the area of the triangle is equal. I will round it to, let me check how many decimal places, round it to 2 decimal places over here. So this is .2f \n, and this is the value for area. So now I am printing, you see, %.2f. Again, I am rounding the value of this area, which is a floating point number. It's a double or a float. So I am rounding it to 2 decimal places. Alright, now let me run this. Give me the value for the side opposite 30, and since I am able to read real numbers, let me say this is a 3.5. Do the calculation. So the area of the triangle is 10.61. You see, I did not calculate the square root of 3. You can try it on a calculator and see how accurate this value is. Alright, now let me go back to the slides. This was my first exercise, and this is the math.py. You see, radius times radius. This is how I use it. Now we know that radius times radius, you can replace it with math.pow. Now the class math, it has several, few constant values. These are the ones that you can use. This is the value of pi. Of course, no need to memorize it. You just use the math.pi, and there are several methods you can use. Make sure make sure to read these methods. Read these methods, understand what they are. Some of them are quite obvious, like for example max. This will calculate the highest of the two values. Min, this will calculate the lowest of the two values. POW, I have used it, something to a power. ABS, absolute value, it will always give you the positive value. SQRT, I have used it, this is the square root. Now cosine, COS, sine, SIN, tangent, TAN, these are very simple, straightforward. Logarithm, LOG, exponential, e to the power x. You see, all of these are quite obvious. Now I only have probably the seal and the floor, which, and maybe there's the round. Yeah, it doesn't give you round over here, it is listed later on. Anyway, let's see the seal, floor, and rounding. Now there are some examples over here. You see round is listed at the end. You can see round, it's easy, it performs rounding. Now let me go to seal and the floor. You see, this is an excellent slide. This is an excellent slide. Take a look at the value 1.8. Seal is always the ceiling, a value that is above this number. And floor is always the bottom, a value that is below this number. When I say a value, it's an integer, I mean. So the ceiling of 1.8 is the first integer after 1.8, it's 2. The floor of 1.8 is the previous integer, it's 1. Now what do we do with the negative? Seal is like the ceiling, above. So minus 2.4, the ceiling is minus 2, and the floor, which is the bottom, the ground, the floor is minus 3. So here's the values given. Math.seal of 1.8 is 2, math.floor of 1.8 is 1, math.seal of minus 2.4 minus 2, math.floor minus 3. Alright, so these are the seal and the floor. Now this is an example calculating the one of the roots of a quadratic equation using the discriminant. It shows you how it can be written in Java, so make sure to try to do this yourself. Try to hide it and see if you can convert it. You can use parentheses as much as you want to make it easier for you to determine values. You see that the top value is being divided by 2 times a. So this is the top value divided by the 2 times a in parentheses. Anyway, and you can continue all the rest. Now in case you are not sure about the precedence, use parentheses. Loops. Let me go now into loops. Now I will come back to this slide and I will do this example in the next one, but first let me go to my flowchart diagrams, and this time I will be drawing the flowchart for a loop, the logic of a loop. Actually, let me keep the slide. You see, I need to calculate the sum from 1 to 10. Okay, the sum of numbers from 1 to 10. So I will do the flowchart based on this logic. Let me start by the symbol to start, and let me put over here, this is start. Again, let me erase the font. Alright, let me prepare the stop. This would be at a later stage. Stop. Now I need to perform some repetition. However, I need to set some values. Like, now that we know programming, I need to calculate the sum and return it to the user. So I need, first of all, to prepare some variables. For example, I need the sum to be initialized to 0. This is the first value that I will base the sum on. So when I start, let me put this connector over here. When I start, I need to directly calculate or directly initialize the value of sum. Now I need to start my loop calculating the value of the sum. Now before I do this, you see, the value of I is initialized. Now sometimes the flowchart will not be identical to how you write the program, but they will have the same logic. You see, you will have the same explanation, but which statement is written, or where do you write the statement, this doesn't necessarily be in the same place. So you can write sum equals 0 and I is equal to 1. This is my first value. Here, let me reduce the size to have them on top of each other. Maybe I reduced it a lot. Alright, I might need to put a new line. Here it is. No need for a new line. Alright. So now I initialized two values, sum to 0 and I to 1. However, when we do it in a for loop, we might initialize the I inside the initialization statement of the for loop. We will see this at a later time. Now let's continue just with the logic. Now after you initialize, you need to add the value of I to sum. Sum is equal to sum plus the value of I. Let me increase the font, increase the size of this thing. And put it over here. Now this is statement. Alright, let me use the lowercase for sum just to have it as if it is a variable, and the lowercase for sum over here. Alright, now this is statement. You see, sum equal to sum plus I. This is a statement that I need to repeat as long as the value of I is less than or equal to 10, because I need to calculate the sum from 1 to 10. So before I do this, I need to check, I need to perform a test. Is I less or equal to 10? You see, this is the test that I need to perform. Is I less or equal to 10? Now this has two outcomes. The first outcome is the yes, and the second outcome is the no. So let me put over here, let me modify this a little bit. So I have the first outcome, which is definitely true. So I'll put this over here, and let me get plain text. This is true. So if I less than 10, add the value of I to sum. We will see where should we go after this. And in case it is false, let me prepare the false right away. In case it is false, I is not less than 10, then this is it. I already have the value of sum. I might need to present it to the user. So let me go to the flowchart symbol. Let me provide output over here. Put the stop at the bottom. Okay. Put the false over here. And output value of sum. Alright, now let me fix my connectors. this is the path if the condition is false, and once I am done I will go over here. Alright, you see I just presented the condition. That if I is not less or equal to 10, exit the loop, go and provide output, this is it, and then stop the program. If I is less or equal to 10, add it. Now I need another value of I, and I need to go back and recheck the condition. So another process, or instead of adding another one, once you add the value to sum, you can put over here, okay, let me add it, I is equal to I plus 1. Just increase the value of I. Now I have two proper operations. You can put them as two different processes, or you can put them in one. So this is a compound statement. This is the body of the loop. You see, if the I is less than or equal to 10, add I to sum and add the value of sum by 1, increment sum. Now I can go directly to one of the locations. Well, you are free to do it anywhere you want. You can put a connector if you want to, and you can go from this place to the connector, alright, let's put the connector over here. You can go, let me put this one over here, you can go from this one to the connector, and of course you can go from the connector all the way over here. So now this is my logic, this is my flowchart, this is my algorithm for a loop. I will perform this into a program, but you perform your initialization, and then you go to the test condition. If the condition is true, then do the loop body and come back to the condition. You see, this is the loop. You are repeating. True, process, go back. True, process, go back. True, sorry, I lifted it by mistake. Process, go back. True, process, go back. This is just repeating. This is repetition. This is a loop. False, that's it. Provide output and you stop. Alright, let me code this. I will open NetBeans. Let me use the same program. Let me keep the scanner and everything ready. I might need them at a later time. Now, and for this program I do not need my scanner. Here, let me remove them. This is going to be a little bit annoying. I will add them when needed. Let me do this, calculating the sum from 1 to 10. So let me declare integer sum semicolon, or I can directly initialize. So integer sum equals 0. And I told you, even though I can declare my I over here, so it might be better to just simply use it in the for loop, because this is a variable that only belongs to the for loop. So for int I equals 0, I less than 10 I plus plus. You see, I did a mistake. If I go back to my algorithm, when I started the algorithm, you see, I mentioned that I should be 1 and I need to test I less or equal to 10. So here's my code. Remember that this code, if you read this for loop, you see I 0, you are adding 1, so 1, 2, it will keep on adding, and the last value is strictly less than 10. The last value is 9. So this is not what I need. I need the loop to start with 1, not with 0, and reach 10. So I need the following. I need the values of I to be 1 and the last value to be 10. So I should start with 1. And of course you can put less than 11. But I mean, why do this? Just put 10 put less or equal. Well, it is correct to put less than 11, but this way it's better. Now read it. I starts at 1. You are increasing 1, so 1, 2, 3, 4. And the last value to be included is the value 10, because I is either less, means everything before 10, or equal, means 10 is included. Now you can add sum plus equal I, or you can say sum is equal to sum plus I. This is the same as saying sum is equal to sum plus I. So I use the compound statement. Now this is it for my for loop. Of course the curly braces were not really needed because I had just a single statement over here. You could remove them, but it's fine to keep them. Now let me provide the output. System.out.println, or let me use printf. The sum is equal, and when you have an integer, use %d \n, comma, and this is the value of sum. Let's run it. The sum is 55. You can try it yourself on a calculator, and or piece of paper, doesn't matter. You can see that the value will be 55. So if you add 1 and 2 and 3 and 4 all the way to adding 10 as well, you are going to get the value 55. Alright, now let's do one of the, this is quite obvious, let's do one of the exercises on meeting 4. Here, let me go to the exercises. I will do exercise number 3. Prompt the user, this should be over here, not to 10 integers, to enter 10 integers. So ask the user to give you 10 integers. The program should count and print the number of positive integers, negative integers, and zeros entered by the user. So I will do this exercise 3. Here's my NetBeans. Now I need to, here, let me remove this code, and I will be having an empty application. Let me start. I need to take input from the user. Import java.util.scanner, prepare the scanner, and definitely the first line, declare the scanner. Scanner input is equal to new scanner of system.in. Alright, now I need so many variables. First of all, I know I need the number of number of values the user is going to give me. So int, I will call this number, or you can say number of values or whatever. So this is a number. Actually, I do not need it. I know it is 10. I know it is 10. According to question 3, the value is going to be 10. So no need for declaring a variable. But you need to count positive, negative, and 0. So I need the count positive and initialize it to 0. We will assume that there are no positive values already. Count negative, initialize it to 0, and count 0. This is initialized to 0 as well. Alright, now let's take the values and do the check. Well, I will do it in a simple way. First, you can give a prompt several times, or you can let the user enter all the values together. It doesn't matter. So if you need to give the prompt several times, you can say start the loop for int I equals 0, I less than 10, I plus plus, and put the prompt inside the for loop. I will do this and then I will modify it. Now first let's check the values of I. I is equal to 0, 1, 2, I will write them all, it's okay. 4, 5, 6, 7, 8, 9 is the last value. Count them. These are 10 values. So I will take 10 values from the user. Now, system.out.print. Enter an integer. Read the integer from the user. So I need another declaration. I will call this the number the user is going to provide. So number is equal to input dot next int. Now this way the user is going to see enter an integer and you took it, enter an integer and you took it. Before I continue, you see I will be continuing, but before I continue let me show you what I'm talking about. I placed the prompt inside the loop, so the prompt is going to be repeated. The whole loop body will be repeated. So enter an integer. Here, let me make this okay, no need, let's keep it. Let's say 9. Enter an integer. -4. Enter an integer. 0. Enter an integer. 3. Well, this is a little bit annoying. This is not trunc. You can provide the prompt several times, or you can simply provide one prompt and tell the user to enter that number of integers and just read them in a loop. So let me stop this program. Okay, it's stopped. Let me come over here. I will remove this prompt. I will put it before the for loop. Enter 10 integers. Enter 10 integers. And take every number. Once you have the integer, once you have the number, perform the check. If number is greater than 0, then count positive should be incremented. So count positive plus plus. It's a positive number. Now you have the choice. You can put an else over here, or instead of nesting the ifs together, you know that if this condition is false, it doesn't need an else. You can test a new condition because the number cannot be greater than 0, less than 0, or equal to 0 at the same time. So just put another if. If number is less than 0, count negative plus plus, increase the negative counter. If number is equal to 0, the count 0 plus plus. Alright, so now I have the number, whether it's greater, less, or equal to 0, all together, separated, each one in a different if, and I have all the values set properly. If you wanted to nest them, you would have written else. Now it is nested, and this last one is just an else. You see, this is a nested if else. So if it is greater than 0, no, check if it is less than 0. If neither, then this last else does not need an if, because this means that it is 0. So you can write it this way, or you can write them separated this way. Alright, now this is it. My loop finished. I read the 10 values and I checked if it is greater, less, or equal. Now I can provide output system.out.println positive values. I will concatenate it to count positive. System.out.println negative values. I will concatenate it to count negative, and system.out.println zeros, I will concatenate it to count 0. Okay, now I will be modifying a little bit, still some modification, but first let's check if this program works properly as required. Here, let me remove this comment. No need for it anymore. We already know how the for loop is working. You see, I am nesting an if inside a for. Now let me run it. Enter 10 integers. I can put them on one line. You see, the prompt is once. Now the for loop will read them. The for loop will read them. So now the program is waiting for the input, waiting for you to press enter. But make sure to provide 10 values, because if you press enter without 10 values, you see it's still waiting. It is still waiting. So you can provide one value, press enter, it is still waiting until you give it the whole 10 values. I will run it again and put them on a single line. This would be nicer. But you are free to put them each on a line by itself. So 9, and I have negative 9, I have a 0, I have 18, I have 16, I have negative 3, I have another 0, I have 4, and now I already have 8 values. I have 7, of course do not put commas, it would be wrong, and let me put another 0. Alright, these are my 10 values. Enter. The program read them all. It was able to count 1, 2, 3, 4, 5 greater than 0, 1, 2 less than 0, and 1, 2, 3 zeros. And this is providing the output. I just provided positive values, negative values, and the zeros, and I gave all my values. Alright, here's the program altogether. Now this is it for this program. However, I will do one modification. You see, what if you need a program not to have a fixed number, not always less than 10? What if I need to ask the user for different values? I need to ask the user for different values. You see, now this program is clear that it only works with 10, because I have it written over here, and the loop works 10 times. So maybe I need another program, or I need to modify this program so that this value is not a constant value, and this value is not a constant, and I can let the user give me this value himself. So let's add another variable, num of values. Give a prompt, system.out.print how many integers are there. Read it. Num of values is equal to input dot next int. Alright, you see, before reading the 10 values and checking them, before doing all this part, I am reading how many integers do I have. Now this is very easy. The for loop should be less than or equal to num of values, or less than if you are starting with 0. If you started with 1, you put less or equal. If this is confusing, the I, you are not using it. Now from 1 to 10, this is 10. From 1 to 5, this is 5. From 1 to 20, this is 20. So you can start with 1, put less or equal, or you can keep it 0 and strictly less than. It doesn't matter. The problem is this value. This should not be part of the string. So I need to end the string over here and restart the string over here, and between these two strings I need to put the num of values. Okay, now I will ask the user how many integers there are. The user is going to give me a value. I will tell him enter that much integers, and I will read that much integers and process them. Let's run it. How many integers are there? 6. Enter 6 integers. You see, I read the num of values, I used it. Enter plus the value 6 plus integers. Now the loop is going to wait for 10 integers and check each and every one of them. So let me put 7, -7, 0, 8, 9, and 10. I have 4 positive, 1 negative, and 1 0. Alright, now here's my full code here. Let me reduce the size a little bit, the font. You can see the whole program. This is everything in this code. Everything in this code. Alright, now I will go back to the presentations. Okay, this is where we stopped. This is calculating the values of sum. There's another example over here, factorial, and try writing the code to calculate any factorial entered by the user. You can do these as practice. However, be careful with factorial. Do not give it large numbers. You will run out of space. Maybe you need to use the long. Anyway, try to play with it yourself. However, you might reach a place where you are getting wrong values because of the limit of the size of data. Now, there's another program over here. You can do this program. 100 students took the quiz, calculate the average, and it tells you, like, for 100 students you are giving values, accurate values, but what if you need to read any number? You can take the number from the user and you can use this number instead. You can do this example yourself. It would be an excellent practice. Alright, now another example of a for loop, finding out the highest grade, the lowest grade. You can do this example. Everything is common. Now everything is simple, sorry. Now let me go to the common mistakes with for loops. Of course, one of the problems is adding a semicolon after the for loop directly. Another problem is that if you are declaring the variable I in the for loop, the I cannot be used outside the for loop. You see this over here, this is a for loop with 2 lines only, 1 line and the for, so there's no, the body is a single statement. The I was declared in the for loop, so it could be used only over here in the body of the for loop. It cannot be used outside the for loop. However, if you declare the I outside and just initialize it, then this value of I will exist after the for loop as well. Check the output, and there are several of these exercises where you are declaring or you are adding a semicolon. These exercises are available in a separate document, and the solution is available on Moodle as well. Okay, I briefly mentioned the common mistake with for loops. You see, never put a semicolon. This is not syntax error, this is a logical error. When you put a semicolon, after a for loop, means the body of the for loop is nothing. So this loop is going to repeat 3 times, do nothing, do nothing, do nothing. And then when this loop doing nothing finishes, this line, even though it is indented, you see, this space is now meaningless. This comes after the for loop, so it will print the value of I. At the end of the for loop, the value of I is 3. So this is equivalent to the following: a for loop, and the body of the for loop is an empty statement, and then print the value of I. So I was 0, increase it by 1. 1 less than 3, yes. Increase it by 1. 2 less than 3, yes. Increase it by 1. 3 less than 3, no. You go after the loop, you print the value of I, the value is a 3. But be sure that I was declared before the loop, otherwise this statement would complain about the value of I and will give you a syntax error. Alright, I will stop this recording over here. While loops, I will start another recording with while loops. So this is the first recording for meeting 4. Thank you for watching this video.